Welcome everyone. Welcome to NS Institute. Today we will learn about this carbon fibers. So basically first we will learn about the definition of carbon fiber or what does this term carbon fiber means. So generally in short form we are writing CF to denote this carbon fiber. Generally हम लोग CF use करते हैं carbon fiber को समझाने के लिए and these are basically the graphite fiber. So carbon fibers are actually the fibers having diameter in between this range 5 to 10 micrometers and composed mostly of carbon atoms. These are actually very stiff and these carbon fibers are actually light in weight and they are resistant to action of chemicals. Generally कोई भी chemicals के साथ ये reaction नहीं करता है. They have high temperature tolerance, बहुत ज़्यादा temperature में भी ये काम करता है and they have low thermal expansion. And because of these major properties, these carbon fibers are actually very much popular in aerospace, in different civil engineering, in military, motorsports, along with other competition sports. But there is one problem to use this carbon fiber. That is actually it is very much expensive, or it is comparatively more expensive in comparison with the traditional fibers. So now we will go through this structure of the carbon fiber, how this carbon fiber actually looks like. So that this atomic structure of a carbon fiber is almost similar to that of graphite, consisting of carbon atom layers. Whatever we have seen in the graphene sheets when we were learning this carbon nanotube. So basically these carbon atom layers are arranged in a regular hexagonal pattern, whichever I have shown you in this video. Now these carbon fibers are actually a material consisting of thin, strong crystalline filaments of carbon, and these are actually used as a strengthening material, especially in resins and ceramics. So here I have shown you the shape or the structure of this carbon fiber. So it is basically the sheets of carbon atoms arranged in a regular hexagonal pattern, that is a graphene sheets. So basically these are the same graphene sheets which we have already learned in case of these carbon nanotubes, but the only difference is the way of the sheets interlock. So these are the basic differences between these carbon analogs. That is, in carbon fiber the way that the seeds interlock is completely different. So now we will look into the different types of carbon fibers. So there can be different types of fibers based on the precursor. Precursor means that whatever the raw materials we are using to produce the carbon fibers, so those are known as precursors. So these can be PAN type carbon fiber. So PAN means that polyacrylonitrile. So PAN type carbon fiber means that a type of the fiber produced by the carbonization of PAN precursor. PAN means that polyacrylonitrile. So acrylonitrile is the monomer. Polymer of that acrylonitrile will be named as PAN, that is polyacrylonitrile. So basically the PAN type carbon fiber means that these type of fibers or carbon fibers are produced by the carbonization of PAN. And pitch type carbon fiber means that these are another type of carbon fibers which are generally produced by carbonization of oil or coal, or you can say that pitch precursor, that is the petroleum pitch. Okay. So based on these different kind of precursors, fiber materials, carbon fibers can be named as PAN based, it can be pitch based or mesophase pitch based. These can be isotropic pitch based, rayon based or gas phase ground carbon fibers. So based on the precursors, these carbon fibers can be of different types, but mostly these are PAN based and pitch based carbon fibers. So now we will go through the manufacturing of these carbon fibers. So now each carbon filament is produced from a polymer such as polyacrylonitrile, that is PAN, rayon or petroleum pitch, which is actually known as precursor. Precursor means that the raw material which we are using to produce the carbon fiber. Now the precursor is first spun into filament yarns using chemical or mechanical process to initially align the polymer atoms in a way to enhance the final physical properties of the completed carbon fiber. So this is the manufacturing process. This is the synthesis of carbon fiber. So after we are getting the precursor in this appropriate method, that is the polymerization, then spinning, then rinsing, after post treatment, we are getting the complete precursor of this carbon fiber, that is the pan based or the pitch based. After getting the precursor, then it will be oxidized in the air, and then followed by carbonization, followed by surface treatment and sizing treatment, we will get the carbon fiber. And this is one of the step, that is by graphitization we will get the graphite fiber, or you can say that the graphitic fiber. So basically these are the five major steps to get the carbon fiber, that is a spinning, stabilization, carbonization, treating the surface and sizing. So these are the basic five steps, or you can say that these are in general five processing stages, that is spinning, stabilization, followed by carbonization, treating the surface, and finally sizing. Okay, so these are the five general processing stages. So now we will go through the major steps of getting the carbon fiber or the synthesis of carbon fiber. So synthesis of carbon fiber from pen, we are in this slide we are trying to figure out the synthesis of carbon fiber from pan precursor, that is a polyacrylonitrile. So basically it involves three major steps, that is the polymerization of acrylonitrile, then cyclization, followed by this dehydrogenation, oxidation, and carbonization. So we will go through these all these stages step by step. So first one is the polymerization of acrylonitrile to pen. So this is the monomer, this is the acrylonitrile. First we will have to polymerize that acrylonitrile to pen. So basically in the next stage we will get this pen, that is polyacrylonitrile. After we getting the pen, it will have to be cyclized. So next step is the cyclization. After cyclization we will get this one, right? So this is the third step. In third step, this is the combination of dehydrogenation, oxidation, and carbonization. So just come to the left hand side. So this is the dehydrogenation. Dehydrogenation means that these hydrogens here, these hydrogens will be removed. So basically we will get the double bond in this position. So first step will be the dehydrogenation, followed by oxidation, where we will get this oxygen or double bonded oxygen atom, and finally this carbonization to get the carbon fiber. So basically these are the total three major steps. There is the polymerization of acrylonitrile to pen, then cyclization, and third step is the combination of dehydrogenation, oxidation, and carbonization. All these three steps I have already shown at the left hand side step by step, that is dehydrogenation, this is the oxidation, and finally this is the carbonization to get the ultimate carbon fiber. So in the third step, after this carbonization, or after finishing all these stages, this process of graphitization starts, where nitrogen is removed and chains are joined into graphite planes. And here whatever we have seen in this last slide, so depending upon the precursor to make the fiber, that is generally we are using this pen based or we are using the pitch based. So depending upon the precursor to make the fiber, carbon may be turbostatic or graphitic, or have a hybrid structure with both graphitic and turbostatic parts present. So what is turbostatic carbon fiber? So basically in turbostatic carbon fiber, the sheets of carbon atoms are haphazardly folded or crumpled together. Carbon fibers mostly derived from polyacrylonitrile, that is from PAN, are turbostatic, whereas carbon fibers derived from mesophase pitch are graphitic. So these are basically two types, that is turbostatic carbon fiber and graphitic carbon fiber. So basically those carbon fibers which are actually derived from PAN are actually turbostatic, whereas carbon fibers which are actually derived from mesophase pitch are graphitic. Okay. So this is the overall synthesis of carbon fiber. Now, in case of manufacturing of these carbon fiber, the raw materials used to make this carbon fiber is called the precursor. Precursor, right? So we have already learned this, that what are actually known by precursor. The raw materials which we are using to make the carbon fiber is known as precursor. So mostly the precursors are pan and pitch, right? So based on the precursor, we have already gone through the types of different carbon fiber, that is pan based, pitch based, like this one. Okay, so about 90% of the carbon fibers produced are made from this pan, that is polyacrylonitrile, and remaining 10% are made from the rayon or petroleum pitch. So mostly 90% are pitch based carbon fibers, and remaining 10% will be mostly rayon or petroleum pitch based carbon fibers. So whenever we are manufacturing these carbon fibers, there can be a different kind of challenges, like need for a more cost effective recovery and repair, as these are mostly costly synthesis, and there should be close control required to ensure consistent quality. And there can be something like health and safety reasons, like skin irritations and breathing irritation, whoever is handling to synthesize this carbon fiber. So there are different important properties of carbon fiber. Among these properties, whichever you want to mention, that is these are having very high tensile strength, these are low, these are having low thermal expansion, and these are electrically and thermally conductors. Okay, so these are the most three important properties of carbon fiber: high tensile strength, low thermal expansion, and electrically and thermally conductors. So now we will go through different applications of carbon fiber. We have already learned that these carbon fibers are actually stiff in nature. These are having very high tensile strength. These are actually having very lightweight, and they do not react with the different chemicals. So due to having these kind of properties, they are commonly used in aerospace, in different civil engineering processes, in military, motorsports, along with other competition sports. These we have already mentioned, like civil engineering, sports equipments, aerospace, aircraft industries. We have already learned this whenever we are discussing the definition of the carbon fibers. Now, here we will try to mention a different application of carbon fiber, that is the carbon fiber composite. What is actually carbon fiber composite? Composite means that carbon fibers are usually combined with other materials. दूसरा एक मटेरियल के साथ कार्बन फाइबर को अप्लाई किया जा सकता है, जिसको हम लोग कंपोजिट बोलेंगे. So composite means that carbon fibers are usually combined with other materials. So when it is impregnated with a plastic resin and baked, it forms carbon fiber reinforced polymer. This is very important. What is carbon fiber reinforced polymer? That is when these carbon fiber is impregnated, that is usually combined with a plastic resin, and followed by baking, then it will form carbon fiber reinforced polymer. And these carbon fiber reinforced polymer is actually having very high strength to weight ratio and is extremely rigid, although somewhat brittle. And these carbon fibers are also composited with other materials such as graphite. This can be composited with graphite to form reinforced carbon carbon composites. So that one was carbon fiber reinforced polymer. Now we are talking about carbon carbon composites, that is carbon fiber is composited with graphite. So therefore it is named as reinforced carbon carbon composites, which have a very high heat tolerance. Now again, in practical, the tail of that of an RC helicopter is made of carbon fiber reinforced polymer. Carbon fiber reinforced polymer means, again I want to mention that when it will be impregnated or when it will be combined with a plastic resin and baked, it will form a carbon fiber reinforced polymer. So tail of that RC helicopter is actually made of carbon fiber reinforced polymer. Now we will go through a different application of carbon fiber, that is textiles. So textiles means that carbon fibers are used to weave a carbon fiber filament, fabric or cloth. The appearance of this fabric generally depends on the linear density or the yarn and the weave chosen. Some commonly used types of weave are twill, satin and plain. Carbon filament yarns can also be knitted or braided. Now these will be the few other applications, that is the micro electrodes. So carbon fibers are used for for fabrication of carbon fiber micro electrodes. In this application, typically a single carbon fiber with diameter of 5 to 7 micrometer is sealed in a glass capillary, and at the tip the capillary is either sealed with epoxy and polished to make carbon fiber disc micro electrode, or the fiber is cut to a length of 75 to 150 micrometer to make carbon fiber cylinder electrode. So carbon fiber micro electrodes are used either in amperometry or fast scan cyclic voltammetry for detection of biological signaling. So basically carbon fibers are used for fabrication of carbon fiber micro electrodes. And the last one will be flexible heating. So known for their conductivity, carbon fibers can carry very low currents on their own. When woven into larger fabrics, they can be used to reliably deliver infrared heating in applications requiring flexible heating elements, and can easily sustain temperatures past 100 degrees centigrade due to their physical properties. So this is the overall carbon fiber. We have already learned what is the definition of carbon fiber, how it looks like, what is the structure of carbon fiber, how it can be synthesized, what are the different applications of carbon fiber, and finally these in these different applications, what are the applications of carbon fiber in textile industry. So thank you very much for watching this video, and if you like this video, please share this as much as possible and subscribe our channel. And I will provide you the study material link in the description box. You can go through that link to get the study material. And if you have any doubt regarding this class, you can write in the comment section. We will try to message you as early as possible in that same comment. And once again, thank you very much for watching this video. See you in the next class. Bye bye.